Hello and welcome to my spaceship for this film about parts per million. As you can see, we've got a great view out of the window. So as we watch this film, hopefully you won't get too distracted by that, and by the end of it you'll know what the units parts per million tell us about a solution, and you'll have had a bit of practice at converting parts per million into moles per litre and the other way around, moles per litre into parts per million. So let's start off by looking at what information the datasheet has for us on this topic. Well, if we look on the datasheet, we'll find that we've got this thing here. We've got the fact that parts per million is equal to the milligrams of solute divided by the kilograms of solution. Okay, and here is a unit which we should be really familiar with. It's moles per litre. Moles per litre. Okay, now you can see these are both fractions, right? So if I'm turning one into the other, I should just be able to turn the top into the top and the bottom into the bottom. So do I know how to turn a mass here into a number of moles? Well, yes, I do. I know that the number of moles is equal to the mass over the molar mass of a substance. And I know that the mass of a substance is equal to the number of moles times its molar mass. Do I know how to turn the volume, here we are, the volume of a solution into a mass of solution? Well, might not have had a lot of practice at it, but I can do it if I know something about the density of the solution. So if I know that a solution has a density of 1.03 kilograms per litre, then I know if I've got 1.03 kilograms of it, I must have 1 litre, or if I have 2.06 kilograms of it, I must have 2 litres. So I can make these conversions as well. Okay, so that's the kind of things we're going to be doing. We're going to be converting the top into the top and the bottom into the bottom. That's all we're going to be doing. Very simple indeed. Okay, so here's an example. Right, we are told that we've got some mineral water and that the calcium ions in it have a concentration of 145 parts per million. What does that mean? Well, that means that the number of milligrams of solute divided by the number of kilograms of solution is 145. So, for example, I might have 145 milligrams of solute in every 1 kilogram of solution. What else am I told? I'm told that the density of this solution is the same as that of water. So here we go. What I'm going to try and do is I'm going to turn these units into those. Well, I want to know the number of moles. So the number of moles equals the mass over the molar mass. The molar mass is always given in grams per mole, so I need to have this in grams. So that's going to be 0.145 grams because there's 1,000 milligrams in a gram. And I'm going to divide that by calcium, which has a molar mass of 40.08. Okay, and if I do that on my calculator, I find that that is 3.62 times 10 to the minus 3 moles. Okay? Right. How do I know there's 1 kilogram of solution? Well, I don't really. It's just that I decided that if I had 145 parts per million, that means I've got 145 milligrams in every 1 kilogram. So can I turn that into litres? Well, yes, because I know the density is the same as that of water. Water weighs 1 gram for every milliliter. Okay, or in other words, 1 kilogram for every litre. So I know that 1 kilogram is equal to 1 litre. All right, and if I divide 3.62 times 10 to the minus 3 divided by 1, well, of course, I find that that is 3.62 times 10 to the minus 3 moles per litre. As you can see, it's suddenly just got a bit darker. That's just because we're around the other side of the moon there. Anyway, let's do the conversion the other way. So I'm given moles per litre, and I'm turning it into parts per million. Right, so am I actually told the moles per litre? Well, I'm not told the concentration in moles per litre, but I am told that I've got 1.2 moles of this stuff in every 0.25 litres. Right? Have I got this right? What is the concentration of sodium ions? Sodium ions. Well, there's 2 sodium ions in sodium sulfate. So, in fact, I'm going to have 2.4 moles of sodium ions in every 0.25 litres. Okay? Now, can I turn 2.4 moles into milligrams? Well, yes, because I need to just find the mass, right? This is a mass here, so I'm going to find the mass of solute and divide it by the mass of the solution. the mass of the solute, that is N times big M. We're talking about sodium ions this time, so that's 2.4, because of this, times 22.99. Okay, so I find that I've got how many milligrams? How many milligrams? 55.176 grams. But I need this in milligrams. So once again, I'm going to multiply this by 1,000 this time because I've got that many grams. 55,176 milligrams. In every how many kilograms? Well, let's see. I've got 0.25 litres, right? I know that 1 kilogram of water weighs, 1 litre of water weighs 1 kilogram. So this equals 0.25 kilograms. Okay, it doesn't equal 0.25 kilograms, but it equates to 0.25 kilograms. And if I put that there, 0.25, then I've got my milligrams of solute divided by kilograms of solution. Plug these numbers into my calculator, and what do I find? It's 221,000 parts per million. Okay, so doing these conversions shouldn't be hard. It really is just a matter of turning moles into mass and vice versa, and volume into kilograms using densities. Okay, so have a bit of practice with that, and I'll see you back on our blue planet.